Okay, I'm going to do a couple of video segments for you on division. And the first thing we need to start out looking at are a few terms that are important for students to understand. And that's the divisor, the dividend, and the quotient. The divisor is the number that is doing the dividing. The dividend is the number that's going to be divided. And the quotient is the answer when you finish a division problem. It's important that kids recognize and understand all the different forms or different formats for division. We have the traditional division bracket, or the house as children have usually call it. We have the fraction bar, which is also a division sign. And we also have the division sign for horizontal division. Children need to be able to recognize the divisor, the dividend, and the quotient in all of these formats. So you might want to pause the video here and make sure your children can identify the dividend, the divisor, and what the quotient would be on all three of these examples. Let's move to the next page. Here we have an example of the traditional column division algorithm. And this is what most students would consider division. This is what most parents and even a lot of teachers would consider to be division. But that's kind of a dangerous thing if we're going to consider this division. It is a division process, but it is a process. It's not really the idea of what division represents. In the next few videos in this series, I'm going to teach you or go through the idea of what division actually is as an idea, not as a process. So first let me go through this and say the method that most people would teach children would be that they would look at the 5 and they would say, well, will 5 go into 1? And they would say, no, 5 won't go into 1. So we need to look and say, will 5 go into 11? Well, they'll say, yes, 5 will go into 11 2 times, and that's going to go, so you would multiply 5 times 2 and you would get 10, and then you would subtract, and it would leave you with 1. And then you would bring down the 5, and then you would do the same thing. Will 5 go into 15? Well, yes, 5 goes into 15 3 times, so we would say 3 times 5 gives us 15. Then we would subtract, leaving us with no remainder. So this idea of going into is very confusing for children. First of all, what does it mean? Does 5 go into 1? Or does 5 go into 11? Or does 5 go into 15? What does that mean? Does it mean the 5 is actually going to be put into that number? Or does it mean it fits in the number? Children don't understand what that means. And here's the other thing that's a little tricky. Because we're saying 5 will not fit into this 1, but in reality, and when we teach children to start with, we teach them that as a 100. It's not a 1. So we cannot forget the value or the importance of place value when teaching kids division, or when we teach kids what mathematicians call algorithms. This is an algorithm. Basically, it's a process that makes division an efficient or faster means of dividing. So we say 5 fits into 1. That's a misconception. It's 5 fitting into 100. Well, we said it would not fit into 1, but me and you both know that 5 will fit into 100. So this process of teaching children to divide is a little bit confusing for children. It doesn't develop meaning, and it's not sense making. It doesn't help them understand the process of division. It just confuses. So we need to look at some better methods of division, and let me go a little bit further and tell you the importance of learning division as an idea instead of as a process. Because the algorithm you see here, again, it is just a process. We don't want kids to only learn how to divide by saying 5 goes into 1 or 5 fits into 11. We don't want to do that. Why? Because when we enter the world of fraction division, this is now not going to be helpful. That idea of divide, multiply, subtract, bring down is not a helpful process when you come across a problem that I have written here. You can see that it's 1/2 divided by 4. And in this problem, we don't even set it up in the division house or the division bracket, we have it written horizontally. And unless we teach children the real concepts of division and the types of division, then they're not going to be able to make meaning from the problem you see here. We need to look at two different examples of division, and I'm going to go through those in the next 2 or 3 sessions, but let me give you an idea here. The first kind of division we have to talk about is partitive division, or what we call sharing division. If we learn division as a sharing process, then we can make meaning from the fraction problem you see here. In fact, it's 1/2 shared equally with 4 groups, which will make sense. If we take 1/2 and we split it into smaller pieces, we can share that equally with 4 groups, and we'll end up with 1/8, because you're taking your halves and cutting them into 4 equal parts, which create 8. Well, that concept only works if the dividend is a fraction. What if your dividend is a whole number and your divisor is a fraction? Well, this idea of sharing no longer really helps here. We have 4, and we're going to share that with half a group. Well, that really doesn't make meaning either. So we have to learn 2 ideas about division. The first one was a sharing idea, and the second one is what we call a measurement idea, or a measurement concept. Now we have to change our thinking, and we have to say, well, how many 1/2 are in 4? Or how many halves will fit inside 4 wholes? Well, we know the answer to that would be 8 halves. So, again, we have to be careful. We don't want to teach children that when we divide, answers get smaller. We also don't want to teach children that the big number goes in the house. These are all misconceptions that tend to hurt kids in the long run. So in the next video, we're going to look at sharing division in a very detailed format.